Okay, functions, we started doing row echelon to solve matrices by hand. So in the past, we have done just a regular matrix where we would have something like, let's see, we would have like x, y equals a constant, and x, y equals a constant. So if we had that, we'll do minus, equals, and then we would turn that into a matrix by doing 1, 1, 1, and this would equal 1, -1, 1, and we would have, this would be matrix A, which was our coefficients. We would have x and y right here that we're multiplying, and it would equal this. Well, now we're going to learn something new. So we're going to learn something called an augmented matrix. Basically what this is just another shorthand. Like I've said in the past, mathematicians like to do everything shorthand. We do this shorthand. So basically this right here is your matrix A. These are all your coefficients. So here's the system that we're converting. These are your constant, and this bar is going to imply our variables, which, x and y. Okay, so that's, we just don't have to write it anymore. So going forward, if this is something that you want to use, if you want to use an augmented matrix instead of, so constants, we would call the constants matrix B in our calculator. So it's just matrix B. So if that's the way you want to do it, fine. I prefer augmented. It's a much easier thing to write, but if it's not something you're comfortable with, fine. But for this, you're going to need it. So matrix row operations. So what this means is any two rows of the matrix can be interchanged. The elements of any row may be multiplied by any non-zero real number. So we're going to multiply them by some kind of scalar, but it's only going to go to that row. We're not multiplying the whole matrix. Now we're just looking at things row by row. And any row may be changed by adding to the elements of the row the product of a real number and the corresponding elements to another. Meaning we can multiply a row by a number and add it to another row to create a row. So that's what we're going to be doing. All right, so we're going to interchange two rows. So this is an example. So if I wanted to move row 3 to row 1, the way that I would write this, so see, this is the original matrix. The way that I would write this is right above this arrow, I would say row 1 equals row 3. So that to me shows a shorthand of interchange, and then I would do it. We can multiply any row by any non-real number. Oh, my face is in the way. Okay, so what we're going to do here is we're going to multiply row 1 by 3. So the way that I would write that, the way that I would write that is 3 row 1 equals row 1. So if I multiplied row 1 by 3, then I would get that. And then you can multiply a row by a non-zero number and add it to another. So this one is saying multiply row 3 and multiply row 3 by -2 and then add that to row 1. So the way that I would write that is -2 row 3 plus row 1 is going to equal row 1. That way I know what I'm doing. Okay, so that's how that gets that. So if you multiply all of this by -2 and you add that to 3, this is what you get. Okay, so now let's do an example. So we're going to start with a 2 equation. So Echelon tells us that we want, our ultimate goal is to get every column to have, so like row 1, column 1 would have a positive 1. Row 2, column 2 would have a positive 1. And then if we're looking at a 3 by 3, row 3, column 3 would have a positive 1. So the diagonals are all positive 1s. The other thing that we want to do is anything that has a 1, so row 1, all of the rows underneath it in that column would be 0. So if we look at this 3 by 3, we have a 1 in row 1, column 1, but row 2, column 1 is a 0, and row 3, column 1 is a 0. We have a 1 in row 2, column 2. We have a 0 in row 3, column 2, and then this one doesn't need anything because it's the last one. So that's ultimately what our goal is and what we're trying to do. So we will be doing that with matrices. Okay, so that is called row echelon form, and there is some practice in your homework online. All right, so we are going to start. Okay, let's see. Right here. We're going to take this system and we're going to convert this into a augmented matrix. So I took all of the coefficients right here and I put them in there. So this column represents my x's, this column represents my y's, and this column represents my constants. Okay, so that's what I have. So the first thing I want to do is I want to see, well, look at this, my diagonals are already 1s, but the second thing that we have to have is that anything under a 1 has to be a 0. So we've got to get rid of this. So I've got a 1 here, so I don't need to do anything to row 1, but I do need to get rid of this 3. So what I'm going to do is I'm going to multiply row 1 by -3, and I'm going to add that to row 2, and that's going to equal row 2. So that's what I'm going to do. So what I have to do, my row 1 is going to actually stay the same in my new matrix, as I'm not creating a new row 2. But I am creating a new row 3. So if I do -3 times 1, I get -3. And if I do -3 times -2, I get +6. And if I do -3 times 9, I get -27. And then I need to add this to this. So -3 plus 3 is 0. 6 plus 1 is 7. And then -27 plus 13 is, -27 plus 13, oh, duh, -14. And it's been a long day. -14. Okay, so now that's my new row 2. Oops, kind of wrote that over there. Okay, so I didn't change my row 3. Even though I multiplied it by -3, I wasn't really changing it. I was just changing it in that moment to create my new row 2. Okay, so then the next thing I want to do is my next step is this is a 0, but I need this to be a 1. Well, the easiest thing to multiply to get a 1 is to multiply by the reciprocal. So 7 is really 7 over 1. So the reciprocal would be 1 over 7, which would equal 7 over 7, because top times top equals top, bottom times bottom equals bottom, which is just ultimately equal to 1. So what I'm going to do is I'm going to do 1 over 7 row 2 is going to be equal to row 2. Okay, so I'm going to write that over here. So my row 1 did not change, but my row 2 is going to change. So I'm going to need, I need to multiply. So 1/7 times 0 is 0. 1 over 7 times 7 over 1 equals 1. We just discussed that, so that's 1. And then I have that -14. So -14 over 1 times 1 over 7 equals -14 over 7, which is just -2. Okay, so now I have this figured out. I have my diagonals are all 1s. The number underneath the 1 is a 0. So I've got this pretty much answered. So we said that these represent the x values and the y's. Well, this says right here that 1y equals -2. Well, if 1y equals -2, I know what y is. Well, then I can come back to this one, since this one tells me what that is. I can use that in there. So this row 1 says 1x minus 2y equals 9. Well, I know what y is. We just said that right here. So I'm going to get 1x is minus 2 times -2 equals 9. And then we get that equals x. -2 times -2 is +4 equals 9. We're going to subtract 4 from both sides. And then I get that x, let's write it over here. So then that gives me x is equal to 5. Okay, so then my answers are y equals -2 and x equals 5. So we just solved a 2 by 2 matrix using row echelon. The next video will be a 3 by 3.